Hello friends, Nokul here. Wishing all of you are doing well. Today I am going to discuss a very important chapter of differential calculus, and that important chapter is continuity of a real valued function at any point x is equal to c in its domain of definition. Generally, you will have a question of 4 marks from this chapter, and I will explain this chapter in detail in my two lectures. And if you follow these two lectures properly, then I can assure you will be able to solve maximum number of problems from this chapter by yourself easily. Okay, let's start.
Topic of discussion. DISCESSION. Topic of discussion is the topic of discussion in this lecture is continuity of a real valued function, say fx. Lecture number 1. Date of lecture date of lecture is 26/05/21 Wednesday. Okay. Overview of my discussion. In this class, I will discuss number 1, limit of a function. Number 2, continuity of a real valued function and its properties. Number 3, when a function fails to become a continuous one at any point x is equal to. Number 4, some very important problems of continuity chapter. Okay. One, limit Question: what do we mean by x tends to any number say c? Question mark. Answer: by the symbol x tends to c, we mean x does not equal to c, but x is equal to c plus delta or x is equal to c minus delta, where delta is a very very small positive real number such that c plus delta approximately equal to c and c minus delta approximately equal to. For example, if we take an example, if c is equal to 2, then x tends to c implies x tends to 2. That means x not is equal to 2, but x is equal to 2 plus delta or or x is equal to 2 minus delta, where we can choose delta is equal to 0.00001, 0.00002, 0.00003, etc. So x, so 2 plus delta approximately equal to 2 and 2 minus delta approximately equal to 2, right? This is the concept of x tends to any number c. Now question 2, question 1, right? Question 2. What do we mean by limit of any real valued function at any point x is equal to c in its domain of definition? Question mark. Answer: if we say limit of fx exists at any point x is equal to c in its domain of definition, we mean limit x tends to c minus fx x tends to c minus fx is equal to finite number. Number 2, limit x tends to c plus fx is equal to a finite number. Third, limit x tends to c plus fx is equal to limit x tends to c minus fx is equal to k. Say here, note here k is called the limiting value of fx at the point x is equal to c. Okay. Now we have to remember some important standard limit. One limit x tends to a x to the power n minus a to the power n divided by x minus a is equal to n multiplied by a to the power n minus 1, where n is rational. n is rational. n is a rational number. Number 2, limit x tends to 0, sin x divided by x is equal to 1. X is in radian. Number 3, limit x tends to 0, 1 plus x to the power n divided by x, this is equal to n. n is rational. 4, limit x tends to 0 e to the power x minus 1 divided by x is equal to 1. 5, limit x tends to 0, 1 by x multiplied by log of e to the power 1 plus x is equal to 1. 6, limit x tends to 0, 1 plus x to the power 1 by x is equal to e. 7, limit x tends to infinity, 1 plus 1 by x to the power x is equal to e. Then 8, limit x tends to 0, a to the power x minus 1 divided by x is equal to log e base a, log a base e, a greater than 0. And 9, limit x tends to 0, log 1 plus x base a divided by x is equal to log e base a. 10, limit x tends to 0, sin inverse of x divided by x is equal to 1. And 11, limit x tends to 0, cos x is equal to 1. Okay, you have to remember all those standard limits. Now coming to second question, continuity of a real valued function and its property. Okay, 2. Continuity. Uh, let if a function from defined from our non-empty set A to B such that y is equal to fx for all x belongs to A and y belongs to B, then uh, number one then number one then number first a left continuity left conti left continuity of fx. What is left continuity of fx? A function fx is said to be left continuous at a point x is equal to c if and only if number one f of c exists that is f of c is equal to a finite number to limit x tends to minus c fx is equal to a finite number, and third, limit x tends to minus c fx is equal to f of c. If those three conditions holds well, then we will call the function fx is continuous at x is equal to c point from left side, left continuous. Now b right continuous. Of fx. A function fx is said to be right continuous at a point x is equal to c if and only if one f of c exists, that is implies f of c is equal to a finite number to limit x tends to c plus fx exists, implies limit x tends to c plus fx is equal to a finite finite number. Third, f of c is equal to limit x tends to c plus fx. If those three conditions holds well at x is equal to c point, then we will call fx has right limit. Fx is right continuous, or fx is continuous from right side. Okay. Now, if we take an example, now example of continuous function. Y is equal to fx any number 2x plus 4. Okay. This is a equation of straight line. That means y is equal to y minus 2x is equal to 4. This implies y by 4 plus x divided by 4 by 2 is equal to 1. This implies y by 4 plus x by minus 2 is equal to 1. If we plot this graph in Cartesian coordinate, 2D Cartesian coordinate, obviously, this is O x dash x y, and this is y dash. Then this straight line will intersect the coordinate axis at y is equal to 1, at y is equal to 0, 4 point, and x is equal to minus 2, 0, this point. Then curve this straight line is like that. Oops, it got little. Okay, this is y is equal to 2x plus 4 straight line. An example of continuous function. Okay, now see when we call a function fx is continuous at any point x is equal to c. Question mark. Answer. A function fx is continuous at x is equal to c if and only if it is both left as well as right continuous. Right continuous at x is equal to c, that is limit x tends to c minus fx is equal to limit x tends to c plus fx is equal to f of c. Okay, this implies limit x tends to c f of x is equal to f of c. This is our condition. Okay. Now coming to third point. Here, this is the third point. What is this? is when a function fails to become a continuous at x is equal to c. Third, a function when a function fails to become, when does a function fails to become continuous at x is equal to c. Answer a function fx fails to be continuous at x is equal to c for the for any of following reasons. Any of following reasons. 1. Any of following reasons. 1. Fx 1. Fx is not defined at x is equal to c, that is f of c is not is equal to a finite number. Number 1. Number 2, limit extends to c f of x does not exist. Does not exist. This happens if any of below reason attain. Limit extends to c minus fx does not exist. C minus fx limit extends to c minus fx does not exist. Okay. B limit extends to plus c. Limit extends to plus c. Fx does not exist. And c limit extends to c plus fx and limit extends to c minus fx both exist, but they are not equal. That is, limit extends to c plus fx not is equal to limit extends to c minus fx. Okay. Number 2. Number 3. Limit extends to c fx exist but but limit x tends to c fx not is equal to f of c. Number 4, uh, number 4, limit x tends to c minus fx exist, but limit x tends to c minus fx not is equal to f of c. Okay, and 5, limit x tends to c plus fx exist, but limit x tends to c plus fx not is equal to f of c. Okay, for those following reasons, a function fx is discontinuous at any point x is equal to c. Okay, now there is an analytical definition of continuity. We don't need it. Okay, now example. Fourth point, some important examples of continuity. Okay, let's start. For examples, some important example problems. Okay, one, question number 1, if the function uh, fx is given by fx is equal to x plus 2 when x less than 2 and x square minus 1 when x greater than is equal to 2. Is this function continuous at x is equal to 2? Justify your answer. Okay, answer we know any function will be continuous at any point x is equal to c if it satisfy what? F of c is equal to limit x tends to c f of x, that is limit x tends to c plus fx is equal to limit x tends to c minus fx is equal to f of c, right? Here c is equal to 2 and fx is fx is x plus 2, x less than 2, x square minus 1, x greater than is equal to 2. So f of x at at x is equal to 2 f of x is equal to x square minus 1. This implies f of 2 is equal to 2 square minus 1 is equal to 3. Now limit x tends to 2 minus f of x is equal to x plus 2. This implies limit h tends to 0, f of h tends to 0, f of 2 minus h is equal to limit x tends to 2 minus fx is equal to limit h tends to 0, 2 minus h plus 2, right? This is equal to limit h tends to 0, 4 minus h is equal to 4 minus 0 is equal to 4. This is equal to left hand limit at x is equal to 0, x is equal to 2, sorry, at x is equal to 2. Again, limit x tends to 2 plus fx is equal to, by definition, x square minus 1. This implies limit x tends to 2 plus fx is equal to limit h tends to 0, f of h plus 2 is equal to limit h tends to 0, 2 plus h their whole square minus 1, right? This is equal to limit h tends to 0, limit h tends to 0, h square plus 2h plus 4 minus 1. This is equal to 0 plus 2 into 0, 2 into 0 plus 4 minus 1 is equal to 3. So at x is equal to, so at x is equal to 2, right hand limit is equal to 3. Hence, so f of 2 is equal to f of 2 is equal to, we have 3, f of x tends to 2 minus f of x tends to 2 minus f of x is equal to, we have only we have 4, x tends to 2 minus f of x is equal to 4. The limit x tends to 2 minus f of x is equal to 4, limit x tends to 2 plus f of x is equal to 3. Since limit x tends to 2 minus f of x not is equal to limit x tends to 2 plus f of x, so at x is equal to 2, limit of at x is equal to 2, fx is not continuous. Okay, limit x is equal to 2 point fx function is not continuous. Now example 2, question number 2. Now question number 2 is, if the function fx is equal to 3ax plus b, x greater than 1, 11, x is equal to 1, 5ax minus 2b, x less than 1, is continuous at x is equal to 1, then find out how the values of fx, values of a, b. This is our question. This question was CBSE 2011. And source SND NCERT, the source. Okay. A solution. Answer is here f of 1 is equal to 11, limit extends to 1 minus fx is equal to limit h tends to 0, limit h tends to 0, f of f of uh, f of 1 minus h is equal to limit h tends to 0, 5a 1 minus h minus 2b is equal to 5a minus 2b, and limit h tends to 1 plus fx is equal to limit h tends to 0, f of 1 plus h is equal to limit h tends to 0, h tends to 0, 3a 1 plus h plus b. Okay, this implies 3a plus b. Since fx is continuous at x is equal to 1, so f of 1 is equal to limit x tends to 1 plus fx is equal to limit x tends to 1 minus fx. Both are equal. So 5a minus 3b, sorry, 5a minus 2b is equal to 11. This is equation number 1. And 3a plus b, this 3a plus b is equal to 11. This equation number 2. Solving those by solving these two equations, we will have a is equal to 3, b is equal to 2. Okay. Now question number similar type questions. You can solve similar types question. Question number 3. Question number 3 is find the value of a and b. Find the value of a and b where fx is continuous and fx definition of fx is given by fx is equal to 5 when if x less than is equal to 2, ax plus b if x less than 10 greater than 2, and 21 if x greater than is equal to 10. Solve this question similar way that I solved this last question, this question. This is your homework. Source of this question is NCERT. Okay. Now solve this question number 4. Answer answer f of 0 is k multiplied by sine pi by 2 into 0 plus 1 is equal to k into sine pi by 2 is equal to k into 1. This implies k is equal this is equal to k. Okay, now left hand limit extends to 0 minus f of x is equal to limit extends to 0 minus f of x k multiplied by sine pi by x plus 1, right? By definition of fx here, this is equal to k into sine pi by 2 0 plus 1 is equal to k into sine pi by 2 is equal to k into 1 is equal to k, right? Now 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 limit x tends to 0 plus fx is equal to x tends to 0 plus fx is equal to uh, here definition x tends to 0 plus tan x minus sin x by x cube. This is equal to limit x tends to 0 plus sin x divided by cos x minus sin x whole divided by x cube. This is equal to limit x tends to 0 plus sin x into 1 minus cos x, right, by x cube. We can multiply both denominator and numerator by 1 plus cos x divided by 1 plus cos x. Okay, denominator and numerator is multiplied by 1 plus cos x. This is equal to limit x tends to 0 plus sin x multiplied by 1 minus cos square x by x cube into x cube. This by there is a cos x, cos x into it was, then this x cube into cos x into 1 plus cos x, right? This is equal to limit x tends to 0 plus sin x into sin x square cos sin square x plus cos square x is equal to 1 minus cos x is equal to sin square x equal to x cube into cos x multiplied by 1 plus cos x, right? Is equal to limit x tends to 0 plus sin cube x divided by x cube into limit x tends to 0 plus uh, 1 by cos x into 1 plus cos x, right? 1 by cos x into 1 plus cos x. This is equal to limit x tends to 0 plus sin x by x a whole cube multiplied by limit x tends to 0 plus 1 by cos x into cos x plus 1 multiplication. This is equal to 1 cube multiplied by 1 by 0 1 by x 1 by 1 plus 1 into 1, right? Since limit x tends to 0 sin x by x is equal to 1 and limit x tends to 0 cos x is equal to 1, right? Okay, this is equal to half. So since at x is equal to 0 fx is continuous, is continuous, thus f of 0 is equal to uh, limit x tends to limit x tends to 0 plus fx is equal to limit x tends to 0 minus fx. So comparing all those things, we have k is equal to half. This implies k is equal to half. Okay, now another question number 5. discuss the continuity of fx at x is equal to 0, where fx is defined by this. Okay, this is a very important question. Okay, now to solve this, we need first. Okay, this is equal to f of 0 is equal to 0 by definition. Okay, now limit x tends to 0, f of x is equal to limit x tends to 0, x square sine 1 by x. Okay, let gx is equal to x square and hx is equal to sine 1 by x. Sorry, now sine 1 by x always lies between -1 to 1. Okay, before this sine 1 by x always lies between this and this lies between always this sine 1 by x lies between -1 to 1 for all 1 by x belongs to real number and x not is equal to 0. Okay, this implies mod of sine 1 by x less than is equal to 1. This implies hx is a bounded function in the in the deleted value deleted neighborhood 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 of x is equal to 0, right? Here deleted neighborhood means the neighborhood neighborhood of 0 except 0, because when x is equal to 0 then 1 by 0 is undefined. That's why it is written that deleted neighborhood. Okay, now this now so limit x tends to 0, f of x is equal to limit x tends to 0, g of x into h of x is equal to limit h tends to 0, x square into sine 1 by x is equal to 0, right? Because since limit x tends to 0, gx is equal to limit x tends to 0, x square is equal to 0. Okay, so at x is equal to 0, f of 0 is equal to limit x tends to 0, f of x is equal to 0. So at x is equal to 0, f of x is continuous. Okay, now using same kind of logic you can solve this problem. Discuss the continuity of fx at x is equal to 0, where functional definition of fx is x into sine 1 by x, x not is equal to 0, and 0 x is equal to 0. Okay, similarly say question number 7, you have to solve this question using this logic. This is your homework in one work. Okay, solve this question and this will be continuous. Okay, fx is continuous at x is equal to 0. Okay, similarly here fx is continuous at x is equal to 0. This is your homework. Solve this using the same logic. Okay, now another question number 8, for what value of k fx is continuous at x is equal to pi by 2. Okay, this to solve this question you need first fx let x is equal to pi by 2 plus h. Okay, as h tends to pi by 2, this implies h tends to 0, right? So limit x tends to pi by 2 fx is equal to limit h tends to 0 f of pi by 2 plus h, right? This is equal to limit h tends to 0 k multiplied by cos pi by 2 plus h, right? Pi by 2 plus h by pi minus 2 multiplied by pi by 2 plus h, right? This is equal to limit h tends to 0 uh, minus k into sine h divided by uh, minus 2h, right? This is equal to k by 2 limit h tends to 0 sine h by h. This is equal to k by 2 multiplied by 1, since limit h tends to 0 sine h by h is equal to 1. Using this result, this is equal to k by 2, right? Now this is equal to k by 2. Now f of pi by 2 is equal to 3, given, right? Okay, since fx is continuous at x is equal to pi by 2, so f of pi by 2 is equal to limit x to pi by 2 fx, both are equal. This implies k by, this implies 3 is equal to k by 2. This implies k is equal to 6. Okay, now another question number 9. Solve this question, and this is the source of this question. For what value of lambda the function fx defined by this is continuous at x is equal to 0. Okay, finally I am done. Friends, if this video helps you, then hit a thumbs up and do subscribe this channel to stay connected with me, and please leave your comment. It will help me to make improvement in next videos, and until next videos, tata.